Hello, students. Now we've talked about 11.3, and so I'm going to jump forward to 11.4, and we'll kind of see, oops, a little bit too far. There we go. Wrap this section up with the symmetries, and here we go into, oops, a little bit too far. There we are at the bottom. So what's the idea? In this section, we're going to talk about simple closed surfaces, three-dimensional shapes that we are going to call very similar to polygons, which were simple closed curves. These become simple closed surfaces, so they become three-dimensional instead of two-dimensional. And what you'll notice here is that even like some of the terms that we're going to be using go as low as the kindergarten Common Core standards. Spatial three-dimensional shapes, cubes, cones, cylinders, and spheres. As we continue on through mathematics, we use formulas for some of these, like finding the surface area, how much water will go into this shape kind of thing. Okay, so take a look. I love how they called this sweets. Personally, I like it because we all know that it's Toblerone. It's a triangular chocolate thing. We're going to call it sweets. All right, that's fine. So we're going to kind of take a look at certain shapes. You can see some of them look like this. These two are known as, well, you can think of them as cylinders in this particular case. And over here, we have a polyhedra. And so we're going to use terminology that's very similar to what we did with polygons. A polygon was a simple closed curve made up entirely of line segments. Well, we're going to come up with a definition very similar to this one for what's known as a polyhedra. And a polyhedra is a three-dimensional shape that is a simple closed surface made up entirely of polygons. So again, with polygons, they were made up of line segments. With these, they're made up entirely of polygons. You'll notice that this beautiful shape next to it is a circle. And so because the base is a circle, even though the side, I know it kind of looks curved, but that curve, if you unroll it, looks like a rectangle. So that has a rectangle and then two circles. I'm sorry, unfortunately, that is not a polyhedra because it violates the has to be made of polygons. And you go back to the definition of a polygon, and the circle violates the fact that it has to be made up entirely of line segments. Okay, so a simple closed surface partitions space, three dimensions. Instead of partitioning a plane, it partitions space into three disjoint sets. That is, the points that are on the shape itself, the interior of the shape, and the exterior of the shape. Okay, the set of all points on the surface together with all the points is a solid. So if you take a look, let me make sure. There it is, all the interior points. So everything on the interior. So if you filled the interior up with like water, then the water that's inside and the shape holding the water in is a solid shape. So take a look here. You'll see number of surfaces here. This one looks really nice. It's got triangles on top and bottom, rectangles on the sides. Here it looks like I have triangles all over the place with can't tell what on the bottom. Maybe that's just a horrible sketch, but it does look like it is a solid shape. This one looks like a really nice solid shape. But again, wouldn't meet the definition of a polyhedra. Over here, circle top and bottom, kind of a slanted piece here. Oh, but take a look at F. F fails. It fails because it is not simple. It crosses itself. You could also think of it violating the definition of having three distinct regions. This has four regions because it has two interiors, the exterior and then the shape itself. And this one is a problem because it has a hole going through it, which means it is not an entire solid piece. Okay. Let's see here. So polyhedra, again, poly for many, and hedra or hedra for face or head. So the faces are kind of, if you think about like kind of what could I sit on in a sense, okay? Vertices are, I love this. The vertices of the polygonal regions are the vertices of the polyhedra. What does that mean? It Yes, I know. They really did a number on us here. If we think about a polygon and we think about the points that make up where the line segments intersect, those points are called vertices, the vertices of the polygon. When you translate that over to 3 dimension, you will also have things that look like vertices. It's where the multiple planes, whenever you have 3 planes coming together, that's what you'll have. So we will have all of these as what are known as vertices of the polyhedra. And then, so we have vertices, then we have these things, which are called edges. That's the line segments where 2 planes come together. Okay. And then we have faces. Now, faces are the polygons themselves. Vertices, faces, and edges. Okay. That's what we have for polyhedra. If you think about this for a polygon, we had vertices and edges, right? We didn't have multiple faces because it was just on a flat plane. Now it's 3 dimensional, so we have multiples. Okay. Ooh, let's take a look. Okay, names. The names that we use are pretty consistent. And so what you want to do is picture a shape. If you have kind of a mirrored shape on top and bottom, and if they lie in parallel planes, then that is known as a prism. Some of you might think of the prisms where the light shines through and it reflects into a rainbow. That's the idea. That's where that name kind of comes from. So it has to be the same shape on top and bottom, and then the lateral faces are going to be parallelograms. They might actually be, the lateral faces could be straight up and down, which would mean it's a special type of parallelogram, which is a rectangle. So a right triangular prism is giving you all the clue words here. First off, it is a triangle. That tells you top and bottom are a triangle because we have a prism. The shape has to be the same on top and bottom. The rightness indicates that I have the top shape is directly over the bottom shape, and the parallelograms are actually rectangles. They form right angles. Next up is a right quadrilateral prism. What does that mean? Same shape on top and bottom. That's the prism word. Quadrilateral says it's a four-sided polygon on top and bottom, and the word right indicates that it is directly over the bottom. So I have exactly, it's right up, straight up and down. The sides are all rectangles. Same here for a right hexagonal prism. Understand the right that's being used here to describe a prism does not mean the angles inside the polygon are right angles. It's indicating the lateral faces. Are they forming right angles as you go? So we have right prisms, and then we have this other one, which I want you to picture it like a jello. Like if you think of it like a jello mold, and you like push the top, how the whole thing kind of goes and kind of tips to the side. That's what we have here. And so when it's tipped, and the sides are actually parallelograms, not rectangles, they're true parallelograms, then when it tips over to the side, we've got what's known as an oblique hexagonal prism. Oblique, which just means kind of off at a tilt or off at an angle. Okay. All right. So what do we have? Prism. Prism is going to have 2 bases, a top and a bottom. Then it's going to have lateral faces. Laterals, again, the side faces that make the shape up. And then, of course, you'll have edges, vertices, and there you go. So if you want to think about what would this look like? So if you had a cube, right? Rubik's Cube or not. Okay. Okay, there it is. So you can look and say, well, wait a minute, what's happening here? I have the same shape on top and on bottom. Those are the bases. Then as you unfold the bases, so what I'm going to do is I want to think like I could kind of pop that up in the air, and then I'd have another shape here and pop the other one down. Okay. And then unfold the rest so you can kind of see what this looks like. Okay, so think about taking a cube, make it out of a piece of paper, and then kind of unfold it. And you can see here's the 2 bases. That's the top and the bottom. And then the lateral faces, they work their way around here. And in this case, there are 4 lateral faces. but that ties right back into the type of shape that we have. So it's a quadrilateral. It's a four-sided figure. So yes, we'll have four lateral faces. If we had a triangle, we will have three lateral faces, okay? One for each side. All right. There we go. What is that? Prism. Okay. Prism, not prison. Prism. Phew. All right. Next up, they do give you a little description if you want to kind of say, how can I draw shapes like this? What they recommend is, they recommend doing it this way. I suppose there's nothing wrong with that. But you can create your shape, whatever shape you have first. And then they say create line segments that are equal length. This is where your straight edge / ruler comes into play. So as long as I make them equal length, the next piece is going to be easy. So I need to make them roughly equal length. And the ones in back are going to be behind something, but they need to be the same length. And then what do? So as long as they're the same length, that looks roughly the same. Okay. Now I just connect the endpoints. And as you're looking at the back pieces, you got to be thinking what part of this is going to be up above everything else. Is what I just drew last, is that the top and I'm looking down and in, or the other direction? So if you want the top one to be the first one that you drew, then you would have to kind of say, okay, wait a minute, the lines I drew down here at the bottom, I need to make sure those lines are actually going to be behind. So I won't see those right off the bat. Okay. And then this one coming down in the front. I think I accidentally erased it. Got it. So the solid pieces would be right up here. This is all solid. This is all solid. This top is all solid. That's all that I really can see. The dotted lines help me kind of say what's behind it. Okay. Yeah, when I'm doing it, sometimes you'll see me do like a square, but if you look at their pentagon here, their pentagon looks like a standard pentagon. It doesn't look like it's tipped upwards, which sometimes makes it a little harder to draw. If I'm trying to draw a square, then I may actually draw something that looks like more like a rhombus, and then I can drop my front lines down and I'll do 3 of them, and then I will connect this line and I'll make a line parallel, and that will get me my back piece. Okay. So again, if you draw the same shape here and the same shape here, just kind of vertically above, then you could just connect the lines. It's up to you. It's not an art class, so just do your best. Okay. So we had prism. Next up, new word, pyramid. What is a pyramid? Pyramid is a three-dimensional shape, but instead of having two bases, one on top of the other, you have one base and you connect all of the vertices up to a single point. And that single point has a fancy name. It is called the apex. Okay. So what is this? Pyramid. How many bases? One base. That's it. Now you can have a triangular pyramid. You can have a square pyramid. You can have a pentagonal pyramid. All those things are fine. And then we have to determine whether or not we have anything else. So a square pyramid tells you it's a regular one. Triangular does not mean the base is a regular shape. It just says triangle. So if we want regular triangular pyramid, which is fine, then the base would have to be a perfect 60, 60, 60 triangle. And that would be my base. You could also call it equilateral. Okay. But the regular part is linked to the base, the shape of the base. It's a regular polygon base. The pyramid part is indicating that there's one of those bases, and the rest of the lateral faces are going to kind of tip up to the top, which also means every lateral face will be a triangle. It'll have to be a triangle. And why? Because you have a point on top and then you have a line segment on the bottom and you're tipping up. So when you think about connecting those, you've got to have a triangle. You cannot have anything else. And then the idea of the idea of rightness here with a pyramid. So if you think about the pyramids in Egypt, which is kind of what we tend to think of when we think of pyramids, I want you to picture those pyramids in Egypt are what are considered a right pyramid. That means from the apex, when I drop the apex straight down, you can kind of think of it hitting the center of the shape. Okay, so from the apex going straight down, it hits kind of the center of the shape, forming a nice 90-degree angle. And the altitude, this is typically called the altitude, intersects that at the center of the circle that passes through all of the vertices. So when you connect this down, there's my front, there's my front, there's my side. I can't see the one in the back, so I use dotted lines. And honestly, I'd probably have to come back through here and do some dotted lines for these last two pieces because those, again, can't be seen by the human eye. So we come up here, and then we come over here. Let me choose a different color for the altitude. So if the altitude does come straight down, forms a nice 90-degree angle, and it's at the center of what would contain all of these vertices, then we call it a right pyramid. If you were to take this like a Jello mold and push in one direction, you will get an oblique pyramid. Okay. So there are options for terms. A lot of the terms seem to be very consistent. So they give you some tips on how to draw a pyramid. Now all of a sudden you'll notice that they have this could be a square pyramid, but they finally tipped it at an angle. So that to me is the hardest piece with the way that they've described how to draw the pyramid. But that's totally fine. Okay. And then what we have is if you take a polyhedra and let's just say that it's a pyramid and you decide to cut off the top of it, then it is known as a truncated, right? If you truncate something, you cut something off of it. So this cube, everything about it looks like a cube, except somebody cut a corner piece off, and now the corner slice looks like a triangle. Okay, still a polyhedron because it's still made up of only of polygons, and the sides are all line segments. So it's still a polyhedra, but it's not one of the standard. This is a pyramid. This is a prism. So this truncated cube, you could think of as a regular right prism, but because it's truncated, you could say it's a truncated right regular quadrilateral. And over here, this truncated prism has been done at such an angle coming down that I do form a hexagon on top and on bottom, but it doesn't look like they're in parallel planes anymore because it was cut. And again, the idea of cutting something would be truncating it. Okay. Next up, regular polyhedra. So we had regular polygons, now we'll have a regular polyhedra. A polyhedron is convex, if and only if, oh yeah, so convex and concave still hold. I think it's interesting here they call it convex one, and they put a boldness for convex polyhedra, and then it's concave over here, and they don't put bold. So concave polyhedra has to have a three-dimensional kind of insert into it, that cave-like piece. And what is a regular polyhedron? Well, go back. What was a regular polygon? Regular polygon, all of the edges were the same length, and all of the angles were all the same. A regular polyhedra is a polyhedra whose faces are congruent regular polygons. They all have to be the exact same shape. So the shapes, the polygons, are acting like the line segments. They all have to be the same. But we also want the angles to be the same, but a three-dimensional angle, again, we're talking about those dihedral angles. So what we say is we need it to be convex. There are some shapes you could make by pushing one side in, and it would look like, hey, it looks like it makes sense. But because of that, it doesn't make this shape look like the others. So regular requires convex. And as it turns out, there's not a ton of them. One, a tetrahedron, 4 faces. If you look at the shape is equilateral triangles. There's a cube, Rubik's cube, cubes that dice. something like that. 6 faces, they're all squares. A square is a regular quadrilateral. Next one up is an octahedron. Once again, equilateral triangles. It just happens to be 4 on top, 4 on bottom. So if you wanted to kind of link these two things we've already defined, a tetrahedron would be a pyramid, and a cube would be a prism. So that's how they connect kind of to each other there. Right? This octahedron, the dodecahedron, and the icosahedron, no. There is nothing here that we have term-wise that would map to those. It's not a pyramid, it's not a prism. That's okay. It's still a polyhedra because it is a simple closed surface made up of only polygons. Okay, so octahedron is triangles. Dodecahedron, this is a funky one. I actually have one of these downstairs. We got like a planter that is a dodecahedron that's got glass sides. You can put like succulents in and make it look really nice. So yeah, dodecahedron, perfect. 12 faces, they're all pentagons. And finally, the icosahedron, 20 faces, all equilateral triangles. Okay. The person who studied these a lot, his name was Plato. And basically, when we think of these regular polyhedra, he studied them and proved, hey, there can only be these 5. That's all you can get. And so we kind of we named them after him. So we call them Platonic solids. And there you go. How many regular polyhedra are there? So there's a little description here. We'll probably do something with that in class to kind of look at, hey, how would this actually work? How could we create this? Some of this does relate to something called tessellation or tiling of the plane. And we'll take a look at that. Next up, you're welcome to also think about, we talked about regular. They have things that are called semi-regular. And they're formed by using regular regular polygon regions, but the regular polygons don't have to have the same number of sides. So there actually is a shape that you've probably recognized known as a truncated icosahedron. And a truncated icosahedron is a soccer ball. So a soccer ball has a whole bunch of hexagons, and in the middle of the hexagons is a pentagon. And that continues. That's what goes around the entire surface of a soccer ball. Okay. And the last piece, one of the big pieces we talk about here is how do we visualize these? So if I deconstruct it and I cut it apart, what does it look like when it's kind of laid out? How do I create that? Yeah, so creating these shapes, I do remember when I was in grad school, somebody was doing a part of their thesis on Platonic regular, semi-regular shapes. How could we use them? And what they did is they created these by cutting out cardstock, all the same, and then folding them up to make sure that the sides were the same. And when you fold them up and punch a little hole in the corner, you could connect them with rubber bands. And so they made these huge 3-dimensional shapes that would kind of mirror all of these. So as you take a look at these are ways that we call them a net, N-E-T, and it's just an unfolded way to look at the 3-dimensional shape. Personally, I think it's pretty cool. How to use those. Let's hear what else. I know they just showed Euler. His name looks like Euler, but it's really Euler. And so he actually came up with a fantastic formula that connected the relationships, what's going on with the different shapes. So vertices, faces, and edges were the 3 things that we can measure on a polygon, on a polyhedra. And vertices plus faces is equal to edges plus 2, or you can rework it to make it this way, but that's kind of the relationship that we always get with these. All right, so we've talked about polyhedra, and now we're going to talk about 2 shapes, and we'll probably get to one last shape, but 2 of the big shapes that are not polyhedra that we do study. And these are known as cylinders and cones. So if you take a look, a cylinder looks a lot like a prism. They are identical, with the difference being a prism has a polygon on top and bottom. A cylinder has a circle or some other curved shape. And so if you have a right circular cylinder, that's telling you there's a circle on top and bottom, and that the sides are all perpendicular to the planes. If it's oblique, again, think of the Jello mold, just push it to the side. It's just slanted. I still have a circle on top and bottom, but it's not going to be right angles all the way. And likewise, it doesn't have to be a circle. It could be some other shape on top and bottom. It still creates a cylinder. All right, what do we have? We still have bases. We still have a lateral surface. In this case, the lateral surface is very smooth and connected. It's not kind of jagged like the other ones would be. And since we have a connection between a prism and a cylinder, we'll do the same thing with the next shape, which is a cone. Now, the cone has usually a usually a circle for the base, and then every point on the outside connects up to the apex. So this looks like a prism, a pyramid. A cone looks like a pyramid. It just happens to have a circle for the base. Now, if the apex is directly over the center of the circle, that means it forms a nice 90-degree angle. We call it a right circular cone. If you think of the Jello mold and someone has pushed it off to the side, that just becomes an oblique circular cone. Okay, so that's our names. I think the only other shape that they didn't cover here that I will say we will be talking about is a sphere. So a sphere is definitely not a polygon at all. It's just a three-dimensional kind of analog of a circle. So that would be the only other shape that we would cover here. All right. So that's it. Three-dimensional shapes. We'll be doing a decent amount with them in 11.4. Then, to be perfectly honest, we really won't see them too much in Chapter 12. We'll come back to them in Chapter 13 as we kind of circle back to seeing how do we measure them? How do we use them to create new things? So there you go. All right, off you go.